statistical inference number 3, early morning hustle. You can still see my time probably, can't you? All right, so go ahead and take a moment and read this paragraph. Okay. And pause, of course. Welcome back from your pause. Okay, let's talk about relevant information in this description. So, a health researcher is studying the average daily screen time of college students in the United States. Okay, so ideally, I would argue in that particular paragraph, you can kind of see a sentence. You can see a lot of good information, such as college students in the United States is our population. Make sure you highlight that, right? The average screen time. So it says average screen time. That should give you a hint of what kind of variable you're dealing with. That's the screen time, which is quantitative, right? In the next sentence, it says the sample size of 40. Okay, I guess it was taken. Again, you should be weary on that, because how did they get these 40 random students? Is there but okay. Maybe it's at a conference. Okay, maybe it was at Coachella. I don't know. Each student tracked their screen time for over a week. I don't know if that's sufficient enough, but let's go with the data. It's ideal for us to build that level of critical thinking. The average daily screen time was recorded, which is okay. Just giving you more information regarding the experiment, or at least the study. The sample yielded a mean of 6.8 hours, again, hinting at a quantitative variable, with a sample standard deviation of S is 2.1, okay? Construct a 95% confidence interval. The population mean screen time for all college students in the United States. Okay, so that's our information. SSVA. Let's go. So summary statistics, we have 40 as our sample size. The sample mean is 6.8, and 2.1 is the standard deviation. Right. So with that information, we can plot with the data, more raw data. We plot the information using, again, what kind of visualization is this? Histogram. This is a histogram. Okay, so utilizing histogram, where the x-axis is the screen time and the y-axis is the count, the frequency of each of those observations within bins. I would say this is approximately symmetric. Again, the sample size is quite small. You can see some outliers. One could argue towards the left. I guess I'm not using that screen that much. And so that's that. That's actually big in terms of the assumptions regarding utilizing the z distribution, right? That's symmetric, okay, in unimodal. Thus, we can use a normal distribution. In terms of our analysis, the really big thing that we need to note here, since we're not doing hypothesis testing, what are we doing? Confidence intervals. Is the actual confidence interval that's given to us right here, okay? 6.128 and 7.472. Through those questions, through the concepts, we're going to eventually get to being able to interpret this. But again, the math, the numbers, they're there. They're there. Okay. So from there, why don't you all take a pause, a legitimate pause. I'm going to pause again and drink the remainder of my coffee and answer the following questions. Okay. So PSO, population sample observational unit. Okay. So the population is all college students in the United States, right? And how are we going to make generalizations about this population? We're going to take a sample. We're going to take a sample, which is going to be the 40 randomly selected students from universities across the country. Again, how did they get this information? How did they get this information? We should be questioning that, but still, this is the data that we have. What's the observational unit? Okay, it's going to be a single or each college student. Okay, that's our observational unit. What's the variable? What are we measuring on each student? Their screen time. What type of variable is that? It's going to be, the average daily screen time. Sorry, my apologies. The average daily screen time in hours is going to be a quantitative variable. On a quiz, on an assessment, or a test, I would want you to say quantitative, okay? Quantitative. What is the research question? What are we really after here, okay? We're trying to determine what is the population daily screen time for all college students in the United States. That's indicative of a confidence interval. We're going to use a confidence interval for the one sample T confidence interval for the population mean. So a common question, this is me trying to help. A common question is, how do I know to use a confidence interval or a hypothesis test? If it were to be a hypothesis test, I would have given you a claim in some way, shape, or form. There were no claims in this actual paragraph. There was no claims. I just asked you, what is it? What is the population mean daily screen time for all college students? Okay. And so that's a big hint to utilize a confidence interval. Okay. So in terms of assumptions, we need a random sample, and since n is greater than 30 and our data is approximately normal, we can use the normal, the z distribution. Okay, the z distribution. All right, so the parameter of interest is going to be mu. How do we describe mu? That's the population mean daily screen time for all college students in the United States. Okay, and how do we estimate that? We use x bar. Okay, which is 6.8, the sample mean of daily screen time for those 40 students. Okay, so that is questions 1 through 4. We're zipping right through this thing. Okay, so question number 5 here, it says state the point estimate. Remember, the point estimate is used to estimate mu. So then what is our point estimate? Ideally, hopefully you said 6.8, right? X bar, nothing crazy there. Calculate the standard error. When we calculate the standard error, that is S over square root of n. S over square root of n. So that's 2.1 divided by square root of 40. Like we said in class, let me make sure I write this down as well. Let's see if I have space. Okay. Standard error measures, right, the variability of a sample statistic. Let me be more exact. SE. So if I would do a bunch of samples over and over again, I expect that variability to be measured to be about 0.332. Okay, the variability of that distribution should be about 0.332. So that is what that standard error means. And so we use the standard error to find our margin of error, okay, which is going to be our critical value. I'm going to write that here, CV, times S over square root of n, okay. And so once we do that, we take that 0.332 and multiply it by 2.023. Okay. I know I didn't give this to you in the problem earlier, but I will be giving this to you on an assessment. Okay. 2.023. So therefore our margin of error is 0.672. So we're going to add and subtract that to our point estimate, which will give us our range of values of 6.128 to 7.472. So in terms of our interpretation, we are 95% confident that the population mean of daily screen time for all college students in the United States is between 6.13 and 7.47 hours. That's a lot of time. And ideally, I would say to be the mean average screen time, actually. That's more specific. The average, because each student was giving us their average, okay? The average screen time for all college students in the United States is between 6.13 and 7.47 hours. That is a lot of time. So in terms of what happens if our sample size increases, okay? What happens if our sample size increases? If our sample size increases, that implies that we legitimately have more data, right? Therefore, our estimate becomes better or worse. One would argue it would ideally become better. Our estimate would become a little bit better or closer to the actual population. So therefore, our bands should increase or decrease. Ideally, they should decrease. We will become more certain. We have more data. We should become more certain regarding the actual estimate of the population parameter, the population mean. So it should get smaller. All right. And so with that being said, that is, oh, we're not done yet. I want to know. Put it in the comments. Was that a 1? Was that a 5? 1 being really, really easy. I got this. I know what I'm doing. Right? Or 5. Oh my gosh, this is crazy. Okay, so give me that information in the comments below. Can't believe I'm a YouTuber. And we're done with this video. Thank you.